Okay, ladies and gentlemen, so I know there has been some questions about this review, and so I wanted to take some time to go over a couple of these questions to make sure that they are understood. Now, these first ones, I am going to go ahead and allow you to use your calculator for. Now, if you guys will remember, whenever you are going to be determining the symmetry by either the x, the y-axis, or the origin, you're talking about whether, whenever you graph these polar equations, whether they are reflections by the y-axis, which is right here. In other words, they look the same on both sides, something like that. You could say is, well, let's go ahead and draw a lemniscate. So this right here is a lemniscate, and you can see that it's both symmetrical by the y-axis and the x-axis. You can see that it is symmetrical on both sides of the y-axis and on both sides of the x-axis. It is also symmetrical about the origin. This means that if I were to turn this equation 180 degrees, my apologies, right? We just flipped it on its side, or we just flipped it upside down, it would look exactly the same. There would be absolutely no difference to what this graph would look like. I can see that by just simply flipping it upside down, and it looks exactly the same. Now, let me show you some examples of what would not be symmetric. Now, this is symmetrical by the x-axis. You can see that it looks the same both on top of the y-axis and below the x-axis, meaning that they are reflections, right? Another way you can think about this is if I folded it down, would all my lines touch each other? And they do, but it is not symmetrical by the y-axis, only by the x, and it is not symmetrical about the origin. If I were to turn this upside down, you can see that the bigger part of my circle has switched over to the left side, whereas before it was on the right side. And so that's really all you have to do for these, especially if you're still concerned about what they might look like on your quiz or on your test. Now, there is a proper way to go ahead and solve these using your algebra, and I can go ahead and show you how to do that right now. Now, if you guys will remember your workshop, I gave you these specific tests for symmetry. So let's go ahead and test the first one for symmetry. The first one says r is equal to 1 plus 3 cosine of theta. Now this says that to test for x-axis symmetry, you replace r and theta with a positive r and a negative theta. So you're trying to make you're trying to see whether both of these are going to be equivalent. And what you could do is you could go to your calculator, turn it on. Now I know you guys have the Inspires, but I'm going to be using my TI-83 right now, and I would just plug in 1 plus 3 times the cosine of theta. Now I'm just going to pick any random theta. 1 plus 3 times the cosine of pi. I press enter, that gives me -2. And let's go ahead and see what happens if I change that to 1 plus 3 times the cosine of -pi this time. And it still gives me -2. So both of these are equivalent. That means that it is symmetrical by the x-axis. And you would go ahead and test this equation, this equation, this equation, this equation, and it will tell you whether it's symmetrical by the y-axis or by just the origin. And of course you can confirm by graphing it. So if you feel like it's only symmetrical by the x-axis after you graph it, just confirm by putting it into your equation, putting it into your calculator, and making sure that you are able to prove it using your test. The answer to number 1 is going to be D. It is symmetrical by the x-axis only. Number 6 says that you are trying to figure out the values for theta where r is at its maximum. So r is going to be equal to 2 times the sine of 4 times theta. And you're trying to figure out where r is going to be at its maximum. Now, when you are working with sine and cosine, the maximum that you can ever get for sine of theta or cosine of theta is always going to be equal to 1. So whatever is in here, the maximum you can get for this is going to be 1. So let's try to think about that. If the maximum that I can get for this part right here is going to be 1, what is going to be the maximum that I can get for r? Well, the maximum that I can get for r is just going to be 2 times 1, which is going to be equal to 2. So I'm trying to figure out where r is equal to 2. Now, I don't really need to pay too much attention to this part. All I'm going to focus on is this, sine of 4 times theta. Okay, so since we're working with sine, we need to figure out where is sine at my maximum. Now, since I don't have a square root or a square or anything like that, I can use either 1 or negative 1. This will both get me to my maximum. So I'm looking for where sine of theta is equal to 1 or negative 1. If I was working with a lemniscate, which has the equation r squared is equal to a squared times sine of 2 theta, this is a lemniscate curve. Because I take the square root of both sides to graph it in my function, I cannot use negative 1. So this has to be sine of theta is equal to 1, and you cannot use negative 1. You cannot use that because of the square root. That would make it an imaginary number. So in this case, we're not breaking any rules by using negative 1, so let's go ahead and use it. So I'm trying to figure out where sine of theta, where sine of anything is going to give me 1 or negative 1. Well, I know that sine of pi over 2 is equal to 1. And I know that sine of 3 pi over 2 is equal to negative 1. And the way I know this is just simply by our unit circle. If you're having trouble with that, go ahead and pause and just go look at your unit circle, and you will see that at 90 degrees or at 270 degrees, you have the sine, which is the y value, is going to equal to 1 or negative 1. And so if I'm looking for sine of 4 times theta to equal the sine of pi over 2 and sine of 4 times theta to equal the sine of 3 pi over 2, then I'm just going to attempt to make these equal and figure out what theta is. So 4 theta is equal to pi over 2, and I'm going to divide by 4 on both sides, so I'm going to multiply by the reciprocal, and this gives me pi over 8. Okay, pi over 8 has to be one of my answers, so I can already cross off C and D. And I'm going to do the same thing with 3 pi over 2. So I'm going to take 4 times theta is equal to 3 pi over 2. Sorry about that. 4 times theta is equal to 3 pi over 2. And I'm going to go ahead and divide by 4 on the side, multiply by 1/4, and this will give me 3 pi over 8. 3 pi over 8 is only an answer in A, and so I know that that's my answer. Finding the rectangular coordinates of a point. Well, these are very simple. All you have to do is you have to follow the equation x comma y is equal to r times your cosine of theta, comma r times your sine of theta. And once again, you'll have a calculator, so you'll be able to plug this in. But this is just, well, x is going to equal to the cosine of pi over 2. The cosine of pi over 2, that's just 0. So that's going to give you 0, comma, and then the sine of pi over 2 is going to give you 1. So 7 times 1, that's just going to give you this answer choice right here. That should be B. Let's go ahead and double check. Yes, 14 should be B. Now, if you're having trouble with figuring out how I did that, It's all about memorizing your unit circle, guys. You have to know what the cosine of pi over 2 is. That is just equal to 0. And the sine of pi over 2, sine of pi over 2 is equal to 1. I know this because I know my unit circle. And then when I multiply times my r, which is the 7 right here, well, 0 times 7 is just 0. And 1 times 7 is just 7. So that's how I know that my answer is going to be B. To find two pairs of polar coordinates with the point, for the point where theta is between 0 and 360, and these are my rectangular coordinates, 3 and negative 3. That is all using triangles. So let's go ahead and try this out. So basically what they're asking me to do is they're asking me to go ahead and create a triangle where it has a value of 1, 2, 3, a negative 1, 2, 3, and I have a point right here. I'm going to create a triangle, and I know that this has a length of 3 and this has a length of 3. First and foremost, I'm going to go ahead and find out what this side is. This is my R, and I'm going to go ahead and find that by using Pythagorean Theorem. This is a right triangle, so I can say, okay, 3 squared plus 3 squared is equal to r squared. And so this is just going to be 9 plus 9 is equal to 18. So to find r, I take the square root of 18. The square root of 18 can be simplified to the square root of 9 times the square root of 2, which gives me 3 times the square root of 2, which should be each and one of our answers for r. The hard part is to find out what this angle is going to be. Now, we're looking for this whole angle, not just this one. But this angle right here, we're going to call this angle, we'll call it theta. Angle theta. If we subtract it from 360, 360 minus theta is going to give us our first angle. So let's go ahead and find it out using SOHCAHTOA. Here I can use tangent because I have my opposite and my adjacent angle. So I can say that the tangent of theta is equal to my opposite over my adjacent, or I can say that theta is equal to the arctangent of 1. Now, once again, if you know your unit circle, you know that the arctangent of 1, in other words, where tangent is equal to 1, is equal to 45 degrees. If you don't believe me, you can go ahead and bust out your calculator and look up the tangent of 1. Now I am in radian mode, so I'm going to switch that really quickly to degree mode. It's so much easier to switch between radian and degree in these calculators. That's why I love them. And you get 45 degrees. So this is 45 degrees. And so if this is 45 degrees, then this whole angle is 360 minus 45 degrees, which is 315 degrees. So we know our first angle has to be 315 degrees and 3 square root of 2, which knocks out a couple of these. It's not 45 degrees, and it's not 225 degrees and 45 degrees. How do we get the other polar coordinate, though? Well, do you all remember when I told you that you could face this way and go forward, or you could face in the exact opposite direction and go backwards? That's the same thing we're going to do here. The way we find out what angle this is to go backwards is going to be to take 315 degrees. And we're going to subtract 180 because that's a full half of a turn. So when we subtract 180 from 315, we get 135 degrees. 135 degrees with our negative r. So we're going to take negative 3 square root of 2 and 135 degrees, which will give us this one right here. It's going to be B. This one has negative 3 square root of 3 with 315, and 315 is going to be the positive one, the one that has the positive r. Okay, so really quickly, eliminating the parameter, we can go ahead and do that very easily. When we're trying to eliminate the parameter, especially with something simple like this, x is equal to 3 times t and y is equal to t plus 7. Remember that our goal is to go ahead and get an equation with only x and y. We don't want t anymore. That's the parameter we're trying to eliminate. So the way we do that is we pick which one of these is the simpler equation. In my opinion, the one with addition is simpler than the one with multiplication, so I'm going to go ahead and pick this one right here. And that would usually be the case, my bad. But as you can see, they have all our answers in y equals. So because of this, we are going to go ahead and use our x before we use our y. My apologies. So let's go ahead and solve for x because we want to keep our y as y equals. So we're going to go ahead and solve for x by dividing by, we're going to solve for t by dividing by 3 on both sides, and we get t is equal to x divided by 3. And then we're going to go ahead and plug this in to our t because that's what t is equal to. So y is equal to x divided by 3 plus 7. And let's see if we can find that. Yes, we can. It's right here. This is our answer choice D. Now when we have something like number 17, where x is equal to the sine of t and y is equal to 3 times the cosine of t, always remember that we're trying to get this to eliminate. We're trying to eliminate the t by turning this into one of our trigonometric identities. So we're going to say that this, I want it all to turn into sine squared plus cosine squared is equal to 1. This is our trig identity that we have to remember. The way I go about doing this is I want to get sine and cosine by themselves. So x is already done, but I need to divide both sides by 3 here, and I get y divided by 3 is equal to the cosine of t. Now that I have done this, I can go ahead and replace cosine and sine with my x and my y. Oh, my bad. I mixed these up. This goes here. So x squared plus y divided by 3 squared is equal to 1. Now, I know that this isn't what it looks like in your answer choices, so we're going to have to go ahead and switch this around a little bit. The first thing I'm going to do is I'm going to take x squared plus y squared divided by, I'm going to square this by 9 is equal to 1. And I'm going to go ahead and multiply both sides by 9 to get rid of the fraction. When I do this, I distribute the 9. The 9's down here cancel out, and that gains a 9. So 9x squared plus y squared is equal to 1 times 9 is equal to 9. And look at that. That does have one of our answers. Where is it? Our answer choice B.